Welcome back, and let me start by saying that our student-focused approach is a success. Students consistently value the course very highly, and the CS2 instructors find the students well prepared. Call the course CS1X, with the X being for extra good. Student recommendations to friends have caused increased student demand for the course. We have responded, and class size has gone from 35 to 145, the max possible for a course with an embedded lab. So why is the course successful? Changing expectations is a big one. We want students to be interested in the course. We are successful there. Keeping that interest has been maintained even as class size increased. Students remain interested and fully participating throughout the course. Keeping that interest helps with the departmental goal to prepare and encourage them to become computing majors. Assignment 0 is to have them write a haiku about class expectation and submit the haiku the day before the start of the semester. I tell them, no haiku, no class. We discuss the haikus the first day of the course. It is an icebreaker that serves to alleviate concerns and improve expectations. I always get asked, why haikus? My answer is that a haiku is a form of structured communication, and that programming is also a form of structured communication. So let's use our success in poetry as a springboard for success in digital problem solving. Another topic for the first day of class is Chrestomathics, which I explained for us will be digital-based problem solving. I say we will look at a great variety of problems, from determining someone's data ability, to winning jelly bean contests, to getting the weather for anywhere in the country. These are all problems you can find on the CS1X website. As part of the guided discovery, students are to make use of laptops every class. Because class size has grown beyond more than triple the size of our largest closed lab, students bring their own machines to class. Students who do not own machines are given access to loaners. The students all leave that first class with the necessary software installed, and they've also successfully uploaded the file to the course website. Taking care of this right away ensures that students will be able to take part in active learning. So throughout the semester, we practice guided discovery. I make an analogy to the baby steps promoted by Bill Murray in the movie What About Bob? I even give a copy of the movie to the student who asks the first question in the course, and another one who gives the first answer. I tell them there will be 42 steps taken over the semester that will transform them into being programmers. The splash page for the course website is updated before every class meeting. All the artifacts to be considered, manipulated, and analyzed are made available for use. Problem solving is the focus of every meeting. As I repeatedly explain, programming is problem solving. To be a successful programmer, you must be a capable problem solver. Each meeting is to expand their ability to problem solve. Being a better problem solver cannot be achieved without doing problem solving. So class meetings are interspersed with information transmission on my part, questioning and answering on both our parts, and problem solving and expressing solutions in digital form, also both on our parts. I ask every class, what is the importance of that? What happens if? My reply is, always try it out and tell me what you see. I will often try it out for myself to help everyone understand coding nuances. I routinely comment every class on our steps so far. Another form of communication are epistles posted on the class website. They are letters from me to the students as a whole. The letters can be expanded discussions on current course elements that I want to comment on. They are also likely to be me detailing their accomplishments and questioning whether they realize just how much progress they have already made. For every assignment, for every student, I provide personal feedback on the assignment. If they get it perfect, I acknowledge the accomplishment and thank them for their effort and encourage them to continue in such a fashion. If it's not perfect, I tell them how to improve. As you can tell from the photo, by nature, I am a jolly person who smiles a lot. I want the students to see me as being approachable. I want them to see me as a person, as well as an instructor. To establish ties, at some point I tell them the story of how I ended up being a computer science professor. The story starts off telling how I was a first-generation college-attending guy who wanted to be a physics professor. So when I started college, Out of naivete, I enrolled in the School of Education, thinking a professor had to be a trained educator. When the physics chair learned of my goal, he told me to change to the School of Science, that being a professor had nothing to do with education. I did not believe that, really, but I did transfer. I then got a letter saying my scholarship was gone. It had been limited to the School of Education. I leave that college as it's no longer affordable. I go to another school with a bad taste for professional physics and find the laws of information to be even more interesting than the laws of nature. So, computer science, here I came. To this day, I routinely buy education books because being a professor is about education. Let your students know who you are. Let them know that you're vested in their accomplishments. Now, there's another module on pedagogy. I asked you to go there, listen to it, complete it, and take it seriously. What worked for us during our college education is not necessarily or even likely what will work now. Guided discovery, active collaboration, teaching for success, pedagogies for all, integrated lecture and lab are all different sides of the same transdimensional coin. They are listed separately for stress here, but they are all intimately related with student-focused learning. Knowing how to communicate and use strategies that work for people in general, rather than for people like ourselves, is crucial to being a good professor. Now, some strategies you can try can be gotten from the workplace. Collaboration is routine there. Collaboration is routine in my CS1X. And once we reach a certain point of expertise, paired programming is used. You are likely aware of the idea of paired programming and heard of its applicability to students in general, be it across genders or ethnicities. Paired programming is not the same as group assignment. To get the benefits of paired programming, you need to follow its constructs. So again, consider that pedagogy module. It's time for reflection again. There are two things I'd like you to think about. One is students seeing an instructor as a person. Why was that important for me? Is that important for you? If so, what are your reasons? If it's not important for you, what are your reasons that way? The other is, what are your best pedagogic practices? Thinking about that from time to time is important. In addition, I am curious because I'm always looking for ways to improve.